Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thank you to Dr. Zinat and all my fellow friends. So, for today's lecture, we all are going to present about the floor system, which is concrete floor system. So, me and my team, we have ALEEYSHA Zainal, AMIRAH NOORIHSAN, AFIZUL SUKIMAN, me, Fatin Nursyahirah, and LUQMAN DAMIRI, and AZRAF ROZI. So, for the discussion, we have 4 things that we need to discuss, which is we have introduction, and we have materials, systems, and joints. Okay, next we move to the introduction. So, concrete floor structures. The concrete floor is typically one in which a flat slab is formed of concrete, which is either poured in situ or precast in a factory. So, cast in place concrete floor slabs are classified according to their span and cast form. Precast concrete planks may be supported by beams or load-bearing walls. Okay, next we move to the materials. Concrete is the most commonly used man-made materials on earth. It is an important construction material used extensively in buildings, bridges, roads, and dams. Its uses range from structural applications to pavers, curbs, pipes, and drains. Concrete is a composite material consisting mainly of Portland cement, water, aggregate, gravels, and sand or rock. When these materials are mixed together, they form a workable paste which then gradually hardens over time. Okay, next we move to the system. So we have concrete beams, concrete slabs, pre-stressed concrete, framework and shoring, and we have precast concrete. Okay, so for the concrete beams, reinforced concrete beams are designed to act together with longitudinal and web reinforcement in resisting applied force. Okay, cast in place concrete beams are almost always formed and placed along with the slab they support. Because of a portion of the slab as an integral part of the beam, the depth of the beams is measured to the top of the slab. Okay, and then effective depth is measured from the compression phase to the center of tension reinforcement. Okay, beam width should be equal to or greater than width of supporting column. So, whenever possible, vary required steel reinforcement rather than beam size. Okay, next, the bottom bars are longitudinal bars serving as tension reinforcement in the section of a concrete beam subject to a positive moment. And then truss bars are longitudinal bars when up or down at points of the moment reversal in a concrete beam. And then web reinforcement consists of band bars or strips placed in the concrete beams to resist diagonal tension. Band bars are longitudinal bars bent to an angle of 30 degrees or more when the axis of a concrete beam is perpendicular to and intersecting the crack that could occur from diagonal tension. Okay, top bars are longitudinal bars serving as tension reinforcement in the section of a concrete beam support to the upward bending of a negative moment. Top bars may also be required when the beam's depth is limited and there is no insufficient concrete area to handle the compression to compressive stress.
Assalamualaikum warahmatullahi wabarakatuh, and my name is FARAH and I'll be presenting about concrete slab. So there are 6 types of concrete slab, which is one-way slabs, one-way joist slab, two-way slab and beam, two-way waffle slab, two-way flat plate, and two-way flat slab. So what are slabs? So slabs are constructed to provide flat surface, usually horizontal, in building floors, roof, bridges, and other type of structure. Slab is supported on 2 sides by beams or load-bearing walls. Beams in turn may be supported by girders or columns, and it is suitable for light to moderate loads over relatively short spans of 6 inch to 18 inch. So as you can see the arrow, that is the tensile reinforcement, and there is also a shrinkage and temperature reinforcement perpendicularly to the main tensile reinforcement. And the slab is also supported on two sides by beams or load-bearing walls. Beams in turn may be supported by girdles or columns. Next is one-way joist slab. So a joist or rib slab is cast integrally with a series of closely spaced joists, which in turn are supported by a parallel set of beams. It is designed as a series of T-beams. Joist slabs are more suitable for longer spans and heavier loads than one-way slabs. And the distribution rib is formed perpendicularly to the joist in order to distribute possible load concentration over a larger area. Joist band is a broad, shallow supporting beam that is economical to form because its deep is the same as that of the joist. As you can see the arrow at the center of the structural system picture, the distribution rib is formed perpendicularly to the joist in order to distribute possible load concentrations over a larger area. Tensile reinforcement occurs inside the ribs. Next is the two-way slabs and beam. So a two-way slabs of uniform thickness may be reinforced in two directions and cast integrally with supporting beams and columns on all four sides of the square or nearly square base. So the two-way slabs and beam construction is effective for medium spans and heavy loads as well. And to simplify the placement of the reinforced scale, two-way slabs are divided into columns and middle strips. And the two-way slabs are most efficient when spanning square or nearly square base and suitable for carrying intermediate to heavy loads as well. Next is two-way waffle slab. So a waffle slab is a two-way concrete slab reinforced by ribs in two directions. So waffle slabs are able to carry heavier loads and span longer distance than the flat slab. And for a greater shear strength and movement resisting the capacity, solid hits at the column supports are formed by omitting the dome forms. And the size depends on the span and the load conditions. For maximum efficiency, they should be square or nearly square as possible. Next is a two-way flat plate. So a flat plate is a concrete slab of uniform thickness reinforced in two or more directions and it also supported directly by columns without beams and girders. So as you can see the area, it shows the tensile reinforcement. Shear at column location governs the thickness of a flat plate, and punching shear is the potentially high shearing stress developed by the reactive force of a column on a reinforced concrete slab as well. So the last one for slab is a two-way flat slab. So a flat slab is a flat plate thickened at its column supports to increase the shear strength and moment resisting capacity. So the line is the tensile reinforcement. So the drop panel is the portion of a flat slab thickened around a column head to increase the resistance to punching shear. And the column capital may be used in place of or in conjunction with a drop panel for increased shear resistance. And this is suitable for relatively heavy loads and spans from 20 inch to 40 inch, 6 to 12 meter.
So next, I'll be continuing for pre-stressed concrete. So, pre-stressed concrete is a form of concrete used in construction. It is substantially pre-stressed or compressed during production in a manner that strengthens it against tensile forces which will exist when in service. Pre-stressed concrete is reinforced by pre-tensioning or post-tensioning high-strength steel tendons within their elastic limit to actively resist a service load. The tensile stresses in the tendons are transferred to the concrete, placing the entire cross-section of the flexural member in compression. The resulting compressive stresses counteract the tensile bending stresses from the applied load, enabling the pre-stressed member to deflect less, carry a greater load, or span a greater distance than a conventionally reinforced member of the same size, proportion, and width. So there are two types of pre-stressing techniques. Pre-tensioning is accomplished in the precasting frame, while post-tensioning is usually performed at the building site, especially when the structural units are too large to transport from factory to site. So these are the types of pre-stress concrete. The first one is pre-tensioning. Pre-tensioning pre-stress a concrete member by stretching the reinforcing tendons before the concrete is cast, while post-tensioning is the pre-stressing of the concrete members by tensioning the reinforcing tendons after the concrete is set. So next is the pre-tensioning. Pre-tension concrete is a variant of pre-stressed concrete where the tendons are tensioned prior to the concrete being cast. The concrete bonds to the tendons as it cures, following which the end anchoring of the tendons is released, and the tendon tension forces are transferred to the concrete as compression by static friction. So, as you can see here, this is how pre-tensioning works. First, steel tendons are first stretched across the casting bed into two elements until a predetermined tensile force is developed. Second is, concrete is then cast in formwork around the stretched tendons and fully cured. The tendons are placed asymmetrically in order to reduce the maximum compressive stress that produced by bending alone. And the third one is, when the tendons are cut or released, the tensile stresses in the tendons are transferred to the concrete through contrast. The asymmetric action of the pre-stressing produces a slight upward curvature or camber in the member. And the last is, the deflection of the member under loading tends to equalize its upward curvature. So, this video shows the example of pre-tensioning. So next is the post-tensioning. Post-tensioning concrete is a variant of pre-stressed concrete where the tendons are tensioned after the surrounding concrete structure has been cast. Post-tension members tend to shorten over time due to elastic compression, shrinkage, and creep. The joining elements that will be affected by this movement should be constructed after the post-tensioning process is completed and be isolated from the post-tension members with expansion joints. So here is how the post-tensioning works. First is unstressed steel tendons draped inside the beam or slab form are coated or sheeted to prevent folding while the concrete is cast. Second one is, after the concrete has cured, the tendons are clamped on one end and jacked against the concrete on the other end until the required force is developed. Third, the tendons are then securely apart on the jacking end and the jack removed. After the post-tensioning process, the steel tendons may be left unloaded, or they may be bonded to the surrounding concrete by injecting glue to the annulus spaces around the sheeted strands. And fourth is, the deflection of the member under loading tends to equalize its upward curvature. So here the video shows the example of post-tensioning works.
Thank you, Fatin, for the presentation. Okay, for the concrete formwork and shoring, when a new concrete is laid or poured, the fresh concrete must be shaped and supported by formwork until it cures and can support itself. This formwork is often designed as a separate structural system by an engineer because of the considerable weight and fluid pressure a concrete mass can exert on it. The flying forms are a large section of formwork, including supporting trusses, beams, and scaffolding that can be moved by a crane in constructing the concrete roof or floors of a multi-story buildings. Under the flying forms at the diagram is the lift slab. Lift slab construction is a technique of constructing multi-story buildings in which all horizontal slabs are cast at ground level, and when cured, the slab will raise into position by hydraulic jacks. This is an up-close look of the formwork and shoring diagram. The objective is to support beams and slab forms until the placed concrete can cure and support itself. The temporary support called shoring are used. Adjustable shores are metal or wood and metal shores available with jack or screw type devices for adjusting the elevation of the shores once they are placed. And various fittings can be interchanged at the top for vertical extensions, U-heads and T-heads. For the single post wood shores are cut slightly short of the desired elevation and adjusted by driving wooden wedges under the shore or as its top. After a concrete slab or beams has cured sufficiently to carry its own weight, the original formwork is removed and the slab or beam is reshored until the concrete reaches its full strength. For the brace, T and L heads provide support for beams formed using columns and beams of a constant section and varying the amount of steel reinforcement to carry the imposed load. The shoring must be braced in both the vertical and horizontal planes to stiffen and prevent buckling of individual members of the formwork. And seal may be required to distribute the shoring load over green concrete, fresh concrete. And that's all for the concrete formwork and shoring.
So next, for precast concrete, it can be divided into three parts, which are floor systems, units, and connections. So first of all, for precast concrete floor systems, precast concrete slabs, beams, and structural tees are one-way spanning units that may be supported by site cast concrete, precast concrete, or masonry-bearing walls, or by steel, site cast concrete, or precast concrete frames. It is manufactured with normal density or structural lightweight concrete and pre-stressed for greater structural efficiency, which results in less depth, reduced weight, and longer spans. Fabrication in a factory environment enables the units to have a consistent quality of strength, durability, and finish, and it also eliminates the need for on-site formwork. The units are cast and steam cured in a plant off-site, transported to the construction site, and set in place as rigid components with cranes. The size and proportion of the units may be limited by the means of transportation. It conceals any surface irregularities, increases the fire resistance rating of the slab, and accommodates underfloor conduit for wiring. When the floor is to be pad and carpet, the topping may be omitted if smooth surface units are used.
Next one is precast concrete units. There are 4 types of precast concrete units. So the first one is solid flat slab. Second one is hollow core slab. Third one is single tees. Fourth one is double tees. We go to the first one, which is solid flat slab. So solid flat slab usually used to construct ground floor of a building, and it is it can be quite expensive, but even though it is expensive, it also gives flat soft finish and the flexibility to the designer in designing the building layouts. Second one is hollow core slab. Hollow core slab offer ideal structure section by reducing dead weight while providing maximum structural efficiency. It also much more economical than using solid flat slab because it is much more cheaper. So the third one and the fourth one is quite similar, so I will just explain in general. So single tees and double tees, they are resistant to moisture and corrosion, and also both of them capable to withstand high loads. Can Both of these can usually be found in the underground floor, parking. Next, we move on to precast concrete connection. So before we go deep into this topic, I would like us to know first what is the definition of a connection. We must understand what is a connection. So a connection is a location where two or more elements meet. Doesn't matter what type of material it is, as long as two faces meet, it is considered a connection. So precast concrete connection is very important in concrete floor system. So firstly, it is very important because economic and functional success of a precast concrete structure depends on the connection configuration. For example, one of the type of precast concrete connection is precast slab. So it might be suitable for building A, but it might not be suitable for building B. So the second one is influence, creep, distribution, thermal and shrinkage strain. So the floor system might have future problems if you do not choose a good precast concrete connection. The third one is determine joints performance. The last one is affect deformation because of the ductility of the connection. So next one, the purposes of precast concrete connection. There are two purposes. First one is to transmit forces from the floor to the ground, because the load from the floor needs to be distributed carefully, or else it will cause future problems. The second one is to provide stability or robustness of the floor. Next, types of precast concrete connection. There are four types of precast concrete connection. The first one is precast slab, second shear key, third precast structural tees, and last one is precast beam. So we go to the first one. So the first one, precast slab, it is a connection consists of compression joint on the bearing surface. Okay, so it uses structural load from the floor to make sure the floor slab stay put. So it also need to have a minimum 75 millimeter on where the floor slab is put on top of the beam, because without the minimum requirement, spalling will occur. And to prevent any failure of the floor system, the slab must be tied to the beam by extended steel dowels. So if you look at the first picture, you can see the dash line shows the extended steel dowels. And it also, we need to put high density plastic bearing strip because to act as a buffer. So next we move to the second one, which is shear key. The purpose of a shear key is to maintain the integrity of the structure. So in general, the shear key does not transfer the bending moment, but only transfer the shear forces due to lateral loads of the building, of the floor. So shear key can only be provided if the slab's thickness are around 150 millimeter or less. Otherwise, it's not suitable to use shear key as precast concrete connection. You can see in the picture on how the shear key applied. So you move on to the third precast concrete connection, which is precast structural tees. This precast connection uses steel angle that welded to plates to hold the slab to the support system, which is the beam. It also uses high density plastic bearing, also the same as the precast slab, that we put in between of the floor slab and the beam to act as a buffer. And also it requires 75 millimeter bearing length in order to avoid spalling from happening. And lastly is the precast beam. So it uses steel angle that is welded to plates as connector from beam and floor. Also use high density plastic strip that also act as a buffer. So that's all from precast connection.
So next I will be explaining about concrete joints. So as concrete moves, if it is tied to another structure or even to itself, we get what's called restraint. And restraint causes tensile forces and invariably leads to cracking. So restraint simply means that the concrete element is not being allowed to freely shrink as it dries, or to expand and contract with temperature changes, or to settle a bit into the subgrade. There are two purposes of joints in concrete slabs. First is that joints allow one concrete element to move independently of other parts of the building or structure. And second, joints also let concrete shrink as it dries, preventing what's called internal restraint. Next, going into the different types of joints in concrete slabs. So the first joint is an isolation joint. It isolates the slab from something else, for example, walls or columns. So isolation joints are formed by placing preformed joints material next to the column or wall or standpipe prior to pouring the slab. An isolation joint's material is typically asphalt impregnated fiberboard. Next is an expansion joint. It is used when there is volume change in the concrete. So it forms a break between the concrete and other parts of a structure to allow movement without causing stress, which can lead to cracking. Another common type of joint is a contraction joint. A contraction joint is a groove in a concrete slab that creates a vertical plane that can prevent any concrete problems, such as cracking or water seepage. Lastly is a construction joint. As you can see in the first picture, that is a key joint, and in the second picture is a dowel joint. Both of these joints are construction joints, and construction joints are used for three reasons. First, if there is a disruption in project when any unexpected incident happens where construction needs to be stopped and started again. Second is when material or machinery is not available in the market. And third is when multiple placing of concrete slabs occurs.